Skill practice 4, we are given again an angle and two sides, which means we could have one triangle, one oblique triangle, one right triangle, or either an acute or an obtuse, or no triangle. So either A is less than H, A is equal to H, A is greater than B, or A is between H and B. Those are our four scenarios. Let's write out what we have. We know that angle measure B is 31 degrees, side B is 3, and side A is 6.2. Using our law of sines, we could say that the sine of A over A is equal to the sine of B over B. To find sine A over side length 6.2 is equal to the sine of 31 degrees over side length 3. Multiplying both sides by 6.2, we get 6.2 sine 31 degrees over 3. We then need to use the inverse sine of 6.2 sine 31 degrees divided by 3 to find the angle A. When we find the arc sine of 6.2 sine 31 degrees over 3, we get a negative angle, which can't be a triangle angle, so this forms no triangle. In my calculator, I get undefined. When I used a different program, I also got a negative angle. So both of these are telling me that this is not a triangle. Question 5, again, we have another angle side-side situation. We're given that angle A is 40 degrees. We need to find angle B and angle C. Side A is 22, side B is 25, side C is unknown. So let's start out using the sine of A over A is equal to the sine of B over 25, which is the B value. Multiplying both sides by 25, we get that the sine of B is going to be equal to 25 times the sine of 40 over 22, or the inverse sine of 25 sine of 40 degrees over 22 is equal to 46.9 degrees. Sine is positive in the first and in the second quadrants. So if we have this angle 46.9 degrees, we could potentially have another angle here that also corresponds to that value. So since this is a second quadrant angle, if we took 180 degrees minus 46.9 degrees, we would get 133.1 degrees. If our angle B was 46.9 degrees, then angle C would be equal to 180 degrees minus that 40 degrees minus 46.9 degrees, which would give us 93.1 degrees. If we were talking about that second quadrant angle of 133.1 degrees, then angle C would be 180 degrees minus 40 degrees minus 133.1 degrees, or would be 6.9 degrees. First scenario, we're trying to find side C, so C over sine 93.1 is equal to B over sine 46.9, or C is equal to 25 times the sine of 93.1 degrees divided by the sine of 46.9 degrees. That gives us a C value of 34.1. C was the largest angle, C is the largest side. That looks good. Let's verify the second one. We have C over sine 6.9 degrees equals the B value over the sine of 133.1 degrees. And so C is going to be equal to 25 times the sine of 6.9 degrees divided by the sine of 133.1 degrees, which makes C equal to 4.1. We have two different triangles that could be possible. Triangle 1 has angle A 40 degrees, angle B 46.9 degrees, angle C 93.1 degrees. Side length A 22, B 25, C equals 34.1. For triangle 2, A is 40 degrees, B is 133.1 degrees, and C is 6.9 degrees for the angle measures. A is still 22, B is still 25, but C is now 4.1. That's the second possible triangle. We want to now find the area of a triangle. A triangle has sides 12, 6, and the angle between them is 76 degrees. Let's draw that out. If I was to label this, doesn't matter how I label it, let's call it ABC. Then that means that A side is equal to 6, B side is unknown, C side is 12, angle B is known. So we know angle B, side A, and side C. So then the area is equal to 1/2 side A, side C, sine of angle B, which is 76 degrees. And so the area is equal to 34.9 meters squared. Getting into applications now, we want to measure the maximum height of a water fountain. So a student measures the angle of elevation of the maximum point, and then 30 feet farther away, the angle of elevation is now 18 degrees. We have the eye level of the student, and we want to find the maximum height of the water. So let's draw a picture. Here's an image where we have our water fountain. The maximum point measured from eye level has an angle of elevation of 25 degrees for the first measurement, and then 30 feet farther away, we have an angle of elevation of 18 degrees. And the student is standing 5.5 feet tall. We need to figure out what the height is of the water fountain. So that height is going to be added to 5.5 degrees from the line of sight because we have our 25-degree angle and we have our 18-degree angle, but those are not the complete distance of the height. Let's draw a height down. For this black triangle, that's a right angle. And so if the angle of degree is 25 degrees from angle of elevation, then the angle from the top of the water fountain is 65 degrees. The angle measures for this right triangle don't help us at all because we have no lengths. We only have angle measures. We have no side length to help us figure out how tall that water fountain is. We have a side length with this green triangle that we've drawn though. We know that there is a 30-foot distance from the first vantage point to the second. We know 18 degrees, and we can figure out this small angle that I've drawn in pink one of two ways. We can figure out the supplementary angle here and use that with 180 degrees minus the two angles to find the little pink angle, or recognize that this large angle is part of the large right triangle that's formed by the long green side, which is the hypotenuse, the distance down here, this long side, and then the black height here. That forms a right triangle. And so 90 degrees plus 18 degrees plus something, and then take away the 65 that's already accounted for. So there's two ways that we can do this. We can say 180 degrees minus 18 degrees minus 90 degrees. That's going to give you 72 degrees, but we already have 65 degrees accounted for, which means that that's 7 degrees. So this small angle here is 7 degrees. You could also say that 155 and 25 are supplementary, and then use 180 degrees minus 18 degrees minus 155 degrees to get 7 degrees. Both of those work to give you that angle measure. We can then find what I've identified as side length C using the law of sines. We know angle 7 and side 30 and angle 155 and side C. So side C over the corresponding opposite angle, sine, is equal to side 30 over the corresponding opposite sine 7 degrees. So C is going to be equal to 30 times the sine of 155 degrees over the sine of 7 degrees, which is 104. Well, now I have a hypotenuse and I have an angle of 18 degrees, and I want to find the opposite value. The sine of 18 is equal to the height over 104. Or the height is equal to 104 times the sine of 18 degrees, or 32.1. So this height is 32.1, but then the student is 5.5 feet taller than that. So 32.1 foot plus 5.5 feet equals 37.6 feet. Lastly, we have an 80-foot flagpole located at the top of a hill. An observer, 220 feet down the hill, measures the angle formed by the bottom of the pole to the top of the pole at 17.7 degrees. Wants to know the angle of inclination of the hill to the nearest tenth of a degree. I am given an angle measure and the corresponding opposite side. I'm given a side, and I can find the corresponding opposite angle, which will then help me solve the larger triangle. So I can say that the sine of 17.7 degrees over 80 is equal to the sine of some angle, I'm going to call it alpha, over 220. So sine of alpha is going to be equal to 220 sine 17.7 degrees over 80, or the inverse sine of 220 sine 17.7 degrees over 80 is going to be equal to alpha. That angle measure is 56.7 degrees. If I know that that angle measure is 56.7 degrees, and this is a right triangle, I can then say 180 degrees minus 90 minus 56.7 degrees is equal to the larger angle down here. That's 33.3 degrees. However, we've already accounted for 17.7 degrees, which means the angle of inclination of the hill is 15.6 degrees.